Our next speaker is Kwon from LG Display, where he's working on enhancement of spatial and temporal performances for virtual reality displays, augmented reality displays, OLED lighting, and automotive displays. I'm very much looking forward to hearing his view on next-generation display technologies. Please welcome Kwon.
Thank you. Good afternoon, everyone. My name is Hyeok-Jun Kwon from LG Display, a display manufacturer company in South Korea. The title of my talk is OLED, the future display for autonomous cars. And so I will talk about some our thoughts on the technical direction of automotive displays in the era of autonomous cars. I will start my presentation with introduction, including some technological trends of automotive displays, and then I will address some required performances of automotive displays based on our studies. And then I will end my presentation with conclusion. In the past, automotive displays were just tools for displaying some simple information, just like time, mile per hour, or radio frequencies, or etc. However, machine learning and other technology advance. The automotive industry trend is shifting away from the simple vehicle to infotainment car and autonomous cars. So the role of automotive display is also shifting. In the era of autonomous cars, the drivers can enjoy some various contents like movies or TV shows or games. So the more bigger and better displays will be needed, and the automotive displays will be the key role in the age of autonomous cars. So as an infotainment device with new user experience, automotive displays are getting larger with differentiation in performance, function, and design. These are the three keywords and technological trends of automotive displays. The first one is visibility enhancement. With large size and high resolution, the automotive display should include vivid color, high luminance uniformity, and high contrast ratio, regardless of various driving conditions. And second one is new application, such as transparent displays and mirror displays can provide some new user experience to drivers. And the last one is design innovation. Current displays have uniform rectangular design, so they can ruin the interior design. So a future display should have various forms to be harmony with automotive interior. As you may know, there are two main streams in display types called LCD and OLED. To put it simply, LCD needs a big light source called backlight to express an image. However, OLED do not need the backlight because they are self-luminous type. So far, the main display type was LCD. However, the OLED technology is getting improved, and the OLED market in other applications like TV or mobile is getting bigger. So I will address that which display type is suitable for meeting some mega trends of automotive display. The first required performances of autonomous displays is high image quality. In terms of image quality, the black is one of the most important image quality index. As I mentioned earlier, LCD needs a backlight to express an image. So if we see a black image in LCDs, we may see a somewhat bright black than we expected. It is because the LCD cannot block the light from the backlight perfectly. So it is called hollow artifact, or light leakage, or light bleeding. On the other hand, OLED do not need the backlight. So OLED enables zero nit black, infinite contrast ratio, and no hollow artifact, which are inherently impossible in LCDs. So when we analyze some various automotive contents, there are many cases that bright and dark regions are displayed simultaneously. So black luminance should be maintained regardless of surrounding signals in order to represent creative intent. So we had a test for that. In the figure on the right side, we displayed the black box pattern on the center of the display, and then we measured the luminance of the black box at the different surrounding gray levels. And this graph is the measurement results. The x-axis of this graph represents the surrounding gray levels, and the y-axis represents the measured luminance data. In case of LCDs, the measured luminance was increased as the surrounding gray level increased because of the hollow artifact. However, on the other hand, in case of OLED, we can see the stable data of zero nit black, regardless of the surrounding gray levels. And the peak luminance is also important image quality index. If we see the star field image in this place, most people want to see some clear stars and deep black of sky like display A. So it is important how well a display expresses a small peak accurately. Furthermore, in terms of the safety, the peak luminance is important because the in-vehicle display should not cause loss of information like display B or C for the safety of the driver. Based on the analysis of automotive content, the size of peak highlight appears from 0.05% to 2% of display size. In addition, according to the automotive display standard, the minimum text size of the display content, automotive content, is about 0.02%. It's really small size. So to represent accurate information, automotive display should represent small peaks well. So we also had a test for the peak luminance performance. We measured the white boxes. We measured the luminance of white boxes from the size of 0.05% to 100%. And the below figure represents the measurement results. In this figure, x-axis represents the size of white box, and the y-axis represents the surrounding gray levels. And the colors indicate the measured luminance level. The green color means the maximum measured luminance, and the blue one means that under 30% of the maximum measured luminance. As I mentioned earlier, the most size of peak highlights appears under 2%. So we can see that OLED can reproduce the peak highlights well in the important peak size. On the other hand, in case of LCD, we can see the dim of the peak luminance in the important peak size. It is because LCD reduced their backlight level when in the important peak size to reduce the hollow artifact. The third one is the local contrast. Local contrast indicates how well a display can express images when bright and dark regions are displayed simultaneously. Human eyes can perceive more contrast when the black luminance is close to zero nit. So local contrast can be calculated as the ratio between the white luminance and the black luminance near with the white. So we tested the local contrast performance of OLED and LCD, and this table on the right is the test results. We can see that local contrast performance of OLED is higher than LCD. OLED has about 1 million contrast, and on the other hand, LCD just has just about 20,000 of local contrast performance. It is because of the superior black of OLED, although LCD has the higher white luminance level than OLED. Local contrast can be applied to also colors. Higher color contrast makes more vivid and vibrant colors, even though display have similar color gamut. In these figures, the left one is captured image displayed in OLED, and the right one is captured displayed in LCD. As you can see in this table, the color gamut of two displays is almost the same. However, the color quality of OLED is higher than LCD because of the superior color contrast of OLED. This color contrast effect, you can see this color contrast effect in the automotive contents because we use the color signals as informative signals to increase the visibility of important information. HDR, high dimming range, is a significant technology in display field. In real world, human eyes can perceive the wide dynamic range from 10 to the minus 6s to 10 to the 6s candela per square meter. So HDR display should express both bright highlight and deep black that are closer to how we see them in real world. So HDR displays can provide the differentiated value in terms of image quality compared to the standard dynamic range displays. In the era of autonomous cars, drivers and passengers can enjoy some HDR content like movies or games under the various driving conditions. So HDR performance in automotive displays will be the important image quality index. Then, which display type has better HDR performance? HDR performance can be evaluated by the HDR coverage. HDR coverage means that how well a display can cover the luminance range that human can perceive. In here, the luminance range is represented in the log scale because human eye perceive the luminance non-linearly. So the HDR coverage can be calculated as the ratio between the luminance range of display to the reference range from the black to white. If we set the reference range as the luminance range defined by the ST2084, HDR coverage of OLED is higher about 20% than LCDs. It is because of the non-linearity of human eye. Human eye cannot distinguish well the 600 nit of OLED and the 1000 nit of LCD. On the other hand, people can easily distinguish the luminance difference between the 0.005 nit of OLED and the 0.1 nit of LCDs. So the OLED has better HDR performance compared to the LCDs. From now on, I explain the excellence of OLED in terms of image quality. And from now on, I will talk about the new the expandability of OLED to new application and some considerations for that. OLED can be applied to new displays like transparent displays or mirror displays. However, these displays are in the beginning, so there are some considerations for successful market entry. So the first consideration is the transmittance of transparent displays. OLED can be made transparently because they do not have the backlight, which block the light from the backside of display. However, the transparent display is applied to the automotive. We have to consider the transmittance. In most countries, high transmittance of glass in automotive is required to secure a clear view during their driving. However, opaque layers of transparent displays like TFT backplane and cathode, which they induce reduction of transmittance. So current transmittance spec of transparent display is somewhat low compared to the legal standard. So we are now studying on the improvement of transmittance of these layers. The second one is diffraction. Unlike conventional glass or mirror, transparent and mirror displays have diffraction due to the periodic structure of display pixels. This diffraction phenomena can cause image blur and color variation compared to the normal glass or mirror. So we are also now studying on the quantification and optimization to reduce the diffraction artifact. And also we are now standardizing how to measure the degree of diffraction in the other standard organizations such as IEC or ICDM. The third one is gamma. Gamma means that the relationship between the input gray level and the output luminance of displays. Transparent displays and mirror displays may express some images regarding the outside situations captured by the cameras. And the image quality for that can be affected by the various driving conditions like night, dawn, diffused, or direct sunlight. So the cameras and displays in automotive should use the adaptive tone mapping operators to reflect various driving conditions. But this is somewhat minor thing. And the last required performance of automotive displays is the capability of freeform design. As I mentioned earlier, OLED do not have the backlight, so they can be made very slim. Furthermore, the glass substrate of OLED is replaced by a plastic substrate. We can make it flexible and rollable. So plastic OLED can provide freedom of design because of its flexible and rollable characteristic. So displays can be harmony with automotive interior out of uniform design. These are our conclusion. OLED is ideal display for the era of autonomous cars because of its superior image quality like black, peak luminance, local contrast, and high dynamic range, and expandability to transparent and mirror displays, and design flexibility. However, there are some considerations such as transmittance, diffraction, and display gamma under various viewing conditions for successful market entry of new applications of automotive displays. Thank you.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.